We're on JK, right?
Yeah.
Didn't we make that joke yesterday? Hi, Joyce.
We're making it since
And
Friday.
every day, yeah.
And then you can just put it on top of my desk. J3, use the first degree Taylor polynomial. Hey, what is a first degree Taylor polynomial?
F of C.
It's a tangent line.
Yeah, I know maybe that's why.
Does that make sense?
Yeah.
First degree Taylor polynomial is just going to be f of c plus f prime of c times x minus c. It's a tangent line. So since it's a tangent line, you're just using basically local linear approximation or tangent line approximation. And to figure out greater than or less than, you're still trying to think about the curve being...
So would it be
The concavity is your ultimate test.
would it be f of k plus f prime of k x minus c? You'd be plugging in k, right?
Yes.
Okay.
So you're using the local linear approximation, you're using the tangent line, and you're plugging in at x equals c. C is what you're plugging in for your tangent line. K is what you're plugging in to approximate f of k with little squiggles. And then how do you know over or under? You're thinking about concavity, which means you can just look to f double prime using the Taylor series, or sorry, Taylor polynomial, the next term. Or you could literally just take two derivatives of your Taylor polynomial and then plug in. As we saw yesterday. Didn't we do that yesterday? We saw either you could figure out the coefficient or you could keep on taking derivatives and find a pattern.
Yep.
Okay, good. Any other ones from Jay? Do you want me to scroll down?
Well, I mean, I can look at the...
Okay. J5. If there is no first degree x term, then the value of c about which the function is centered is a critical value.
I was looking at that.
Why is that true? Remember, just whenever we're doing any sort of relative max or min, how many things need to be true?
What?
What needs to be true to have a relative max or min?
Change sign.
First derivative has to change sign at a 0 or a DNE. So yeah, we have to figure out critical numbers first. First derivative has to change sign or
Second derivative has to be...
concave up, concave down at a critical number. So what's in common between both the first derivative and second derivative tests? You have to have a critical number, aka the first derivative has to equal 0. So what are they saying here? Well, if the first derivative equals 0, then the first degree term will be missing. So that's one way to think about it. But long story short, first derivative has to be 0, and then second derivative has to be positive for a relative min, or first derivative has to be 0, and second derivative has to be negative for a relative max. Why aren't they including what if the first derivative does not exist? Isn't that a critical number? But what kind of function are we dealing with? A Taylor polynomial. Is the first derivative ever not going to exist? It could be absent, it could be 0, but it's never going to DNE, right?
Yeah.
Does that make sense? Yeah. You couldn't have a Taylor polynomial and have like a DNE term. That wouldn't work. So that's why they're only considering, well, if you have a Taylor polynomial, just think of when the first derivative is 0 and the second derivative has a positive or negative for the concavity. It's probably the easiest way. That's why they say to go ahead and look at the x squared term. Figure out what the second derivative would be from the coefficient of the x squared term and then test the sign. Any other ones from J? Yeah, call it out if you have one, bud.
It's just on J3.
Yeah.
I didn't really know how to write it, so I just put since the next term has an x squared, concavity makes the approximation under approximation.
Well, it depends, right? It depends on the problem.
I didn't understand what that was saying, and I didn't know.
It says determine whether it's over or under, greater or less. Look at the concavity, aka, this is what I was saying a second ago. Remember how yesterday we learned you could either think about the second derivative by looking at the coefficient of the second degree term, or you can think about the second derivative by taking two derivatives of the Taylor polynomial. Either way, when you are approximating at x equals c, to figure out the concavity, you need to know f double prime of c. So somehow find f double prime, either using the second degree term or using literally taking two derivatives of the Taylor polynomial. Figure out positive or negative, which indicates concave up, concave down, which allows you to make your conclusion as to greater than or less than.
So if f double prime is concave, so if it's concave up, It's over. Concave down, it's under.
Concave up, a tangent line would be below.
No, I mean if the polynomial was concave up.
Then the tangent line would be below.
So,
So under approximation. If concave down, tangent line would be above, so over approximation.
Which way are we coming from?
We're just looking at a point. We're using a tangent line at a point for the first degree Taylor polynomial. And so we're just looking at that point. What's the concavity of f
And if we're approximating,
with the tangent line? If the second derivative of f, which is the same thing as the second derivative of the polynomial, if it's positive, that means my function and my polynomial are concave up there. The tangent line would be under approximation.
does it matter which side we're coming from? Because if we're coming from the right,
Over, doesn't matter. It's all about concavity.
it's just a concave up.
Oh, sorry, under.
It would go up to the left, come up right, and then.
Oh, no, you're doing Riemann sums.
Oh, you're right. My bad.
There you go, you're doing Riemann sums. That would be different. That one you have to think increasing, decreasing. Gerardo.
So if the function is concave up, under, if the function is concave down, over.
Approximation, yes. Yes. J's we're good on?
Yeah.
Okay, K's?
K6.
So
Anything earlier than?
K3, do we have to like write every single one of them? Can we just say go through the tests? There should be, I think.
I mean, it's basically go through the test, but if you were given a multiple choice, and that's the sad thing is, some multiple choice give you many different series and ask which of these converge, which of these diverge. So this is having you separate, if I'm just looking for convergence, this, and this, and this need to be true. So theoretically, it could shorten the work for you if you think about making it more concise and literally just saying this shows convergence this way, this shows convergence. So it's a personal choice. I don't care. But it could help you speed up if you have in your mind these ones prove convergence this way, and then these ones prove divergence this way. But it's up to you. You can keep them totally separate. I don't mind. Gerardo.
For K3, I just started listing all our tests. Is that okay?
Almost, except they were just asking for convergence. So like nth term test doesn't really apply for convergence. You know what I mean? So that's the one warning that I would say.
Then
Anything else?
K5,
Mm-hmm.
I just wrote -1, R has to be between -1 to 1.
Only if it's what type of series?
Geo.
Okay.
And then I put or limit to n approaches infinity, absolute value n plus 1, a sub n plus 1, times x to the n plus 1 over a sub n.
Yeah. Hey, Gerardo. That's the ratio test. So you're good, right?
Yeah, I just wasn't sure if what I wrote out and what they wrote out was like coincident.
Well, as long as you wrote the ratio test correct, you're good. But I would add the geo series. And that's what I said, I think, earlier in class today. I agree. I totally agree. Because geo series, you don't have to check the endpoints. And Amanda, otherwise we check the endpoints.
Yes.
K6, was that the one you were looking at?
Yeah, because it doesn't have a plus dot 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 after it. So is that a series or a sequence?
That was a typo.
It's supposed to have plus
Yeah,
dot dot.
add a plus dot dot dot, guys, on K6. It is the infinite.
Okay.
Alright,
So
so the harmonic series divergent, can we just say the limit? Never mind, that would be done. That's what I knew was wrong. I still.
Yeah. Use P series instead. Gerardo.
For H6 and H7, we went over this in the morning.
Oh, hold on. We're finishing K.
Oh, okay.
Hold on. Any more in the case?
Can you explain K12?
Yeah.
Oh, okay. This is assuming that you were able to find S sub 4, meaning they said something like find the 4th degree Taylor polynomial. I guess 3rd degree. But remember, whenever you have an alternating series, that the error is going to be less than the n plus first term. So they were saying if you're trying to approximate this series, then you would go ahead and find the 5th, that's a typo, sorry, find the 5th term. And you're not necessarily needing to approximate f of x. They're not asking you to approximate the function. Just remember that this subtraction of the actual minus the approximate is the error. So all you're approximating is the error, and the error says look to the next term. Does that make sense? But technically, guys, it's absolute value of the next term, right? For alternating series test for the error bound?
Is absolute value the remainder sub n equals absolute value of a sub n plus 1.
Less than or equal to, but yeah.
Oh, no. I wrote that, but it got erased.
So then make sure absolute value of the next term, because the alternating doesn't really matter.
Is that all we really have to write? Less than the n plus first term?
Yeah. Basically identify this is the error, and using the alternating series test, or the estimation remainder theorem bound? What's that called? The alternating series estimation.
Truncation error?
No, the card.
Oh.
Hey, speaking of cards, forevers and nevers, what should you be studying?
Those. For
Yeah.
numbers?
That's why I'm not giving you guys any new homework tonight. If you guys look, the one you see you think we're going to turn in by the end of today, so if you haven't finished it yet, get it finished, turn it in, just so I can check it for completion. Super easy, cheesy. Huh?
FRQs as well.
FRQs 2016. We should have time to go over the questions, so yeah. Just turn into the tray by the end of the day. And then tonight I just say study, but I do have a few places if you do want to be doing practice problems in preparation for Saturday, but most of you probably just want to study. Bring your forevers and endeavors updated tomorrow. Yeah. Bring them updated tomorrow. Try to.
Two things. The endeavor that we found on the review. That's actually H9. You want us to add that in as endeavor number 32?
Yes. Yes, I meant to update yesterday, but if you were in my room yesterday at any point in time, you saw that life was ridiculous.
Yeah.
I was a little overwhelmed a couple times. Just multiple, two different sets of alumni from two very different years, and lots of people working in a Baja Mission team meeting, and lots of people working.
Oh, yeah, Brittany and Griffin were here yesterday.
Oh yeah, they were here too. Gerardo, any other questions about, you said something about the H's.
Yeah, H6 and H9, is that H6?
H9 is just the endeavor number 32, and H6.
And H7. I think we went over something in the morning.
Yeah, we talked about it this morning
That's not right.
Yeah, we can't.
in the sense of you need to find y prime and x prime.
I put, for H6 I put dx d theta has to equal 0. Oh, sorry.
Yeah, or x prime with theta, but either way.
Oh, very cool. So they did do it wrong.
Yeah,
I15.
I stated that, and you did again, and we started it this morning.
I5. I keep saying I15 every time.
Yeah.
I'm gonna get tutored today, so I could get help on like the FRQ. Can I turn it tomorrow?
I5.
Yeah. It's supposed to be a vector. Why did they put it as a... Like, I put...
You would do it in vector notation. We know that. The side carets. Remember, I don't say that their answers are right. You're just considering their answers and then using our endeavors and our notes to make the best educated
Summary of what you think.
summary of what you think it would be helpful. So I would put the side carets, I would put the comma, and what do they say? Given the velocity vector and position at time 0, find the position vector. You would need to add the initial to each of those integrals, right?
I didn't understand why they would just say plus C when it's just S sub 0. Like that's literally the definition of an integral.
Yeah, they were just being super
Like,
particular.
when I keep writing it down, it's
Well, because what they're doing is they're saying take the integral, find the indefinite with plus c's, and then plug in the x, plug in the y, like the time and with time equals 0 to find the c. I would say use integration as net change and add the initial plus the integral from 0 to x. That's what I would say,
yeah,
but
that's what I've been doing, and then they put the other.
they're trying to make it general, whereas we're making it specific like an AP problem would. And guys, isn't that like the FRQ, not the last one in your test, but the second to the last one? You guys had a problem just like it. Some of you got it, some of you didn't.
Just
The initial plus second to the final. Gerardo, what was the other question, bud?
Okay. I had it in my hand. Oh. I put the carets integral x of t dt plus c, comma, integral y of t dt.
That's one way to do it if you're doing an indefinite and then plugging in the clue. But as I just said, look at the FRQ. The other way to do it is integration is net change, where you have the initial plus the integral from the initial to the final of your x prime and y prime.
Yeah. For some reason, I just straight up integrated it. I derived. I didn't do integration as net change for some reason. Is that a common mistake these days?
Integration of that.
Well, you could technically take either way, but you have to somehow incorporate the initial either to find the plus c or to be there originally.
Oops.
It is a common mistake. It's just one that hopefully we'll remedy, you know? But that's why we have test corrections on that due next week and why I'm giving it to you now to look at.
3 points? Oh, that's a lot.
Yeah,
Well, because
all
you-
went to was-
You got 1 point for each of the correct integral expressions for the x coordinate, for the y coordinate, and for the final answer.
Did you get A?
A? Yeah, I got that.
Any FRQs 2016 questions? Georgie and I were, well, my brain was fried by that point.
Yeah, I understand. I just don't know how to do anything.
But number 6 was a bit of a beast. Anybody else want to agree with that?
Yeah.
So 2016, number 6, just peeking at it real fast, because my brain was fried when someone asked me about it yesterday. Gerardo, refocusing, bud. 2016, number 6.
Oh, yeah, I got it right here.
Letter A was a simple plug and chug, right, cool kids?
Well,
Except,
I didn't get that. Are we supposed
What
to
went
do
weird?
Are we supposed to do 1 over n?
here's the struggle. And this is, I noticed it, Georgie, in time to help with 1, but I didn't
It's
get
okay.
to help with this.
Honestly.
A Taylor series expansion has f of c plus f prime of c
Times x minus.
plus f double prime of c over 2 factorial.
Right. But then how can they do 3 factorial for
Well,
this?
That's what we, uh-oh, did I just get out of whatever the full page was?
Yeah, that's what
Okay. In this next one, if I was to go ahead and plug in f, where am I at? F double prime?
Oh, I see. Because
F, F prime, F double prime, F triple prime, yeah. So it simplifies with factorial.
Yeah, I thought we were supposed to do that, and then
I was seeing this as the
Somebody
nth term. I kept on seeing this as the nth term and not the nth
That's-
derivative.
Yeah, that's what I thought at first.
Yeah.
And then I
Yeah.
just didn't simplify when I put that with, and like combining to make the nth term.
Oh,
So
yeah.
the n minus 1 on the top, and then there was an n factorial on the bottom that I could have simplified and made it a lot easier for the rest
I got
of
the
it.
first 2 terms right because they gave them to us, but
Yeah. Well, also there's no factorial, so then that would have, you know what I mean?
Yeah.
You wouldn't have had the 2 factorial,
one
3
point.
factorial.
Miss D, could you have done conceivably to find the nth term? Could you have plugged f of nth derivative times x minus c over n factorial and simplified, and that would have been your nth term?
Or just not simplified, but yeah.
Oh my gosh, I should have done that.
It's a whole lot easier to see the pattern though.
I'm gonna write that in there.
You do you.
Because like the pattern, I couldn't figure it out.
well, I couldn't either because I didn't know.
Okay. On letter B, well, I don't know. You guys are able to ask questions. I'm just talking about it because my brain was dead, and so I found it interesting. I don't know why, Georgie, the x minus 1 centered at 1, I was making it harder than it needed to be.
If I had the nth term, it would have been easier to. I would have known what to do, but I couldn't find
Yeah.
the general term because I did the multiplying wrong.
No, that makes sense.
Yeah.
And that's what was throwing us off. Gerardo?
D. Am I plugging in my calculator? 1 over 2 cubed times 3 is 1 over 24.
Negative, but yeah.
Right.
An absolute value doesn't matter.
And then it's times 0.2 cubed. I got that to be 3 times 3, 3 times 10 to the negative 4. That's 1 over 30,000. But yet they put 3,000.
So I have 1 over 25 times 1 over 24. What's 24 times 25?
You have 1 over. Well, 24 times 25.
That's 3,000. We're good.
Okay.
Because it's 1/5 times 1/5 times 1/5. So 1 over 125 times negative 1 over 24. 24 sets of 25. 6 sets of 4. 6 hundreds.
It's 1 over 125.
Times 1 over 24.
I was doing the 25 and I was doing the hundreds. Sorry, I was doing them separately.
I get 3 point.
Because I'm seeing 24 as being a 2-digit number, 125 as being a 3-digit number, and then adding a 0.
I still get 3 times 3.333 and the negative 4.
whether it's 3,000 or 30,000, that's still less than 0.0.
Yeah, that's my ultimate. I'm like, you shouldn't be simplifying that anyway, because that's actually a wasted step,
can you
wasting
just
time.
Say that it's less than?
Yeah. Remember on these ones that we talked about? I don't know if they did a typo or not, and there are occasionally typos from the 2016. We could go look at the analysis and see what they say. But long story short, whenever they say show that the approximation is within, guys, just plug in and say within. There's no need, if this calculator, this is a non-calculator problem. We don't care, right? Just say less than or equal to 0.001. Always, always, always.
For that, why are we... Never mind.
Oh, he's gone today.
It's first three terms, but it's to a substitute. That's what it was.
That's like, I was very sad about
The terminology, you have to be really careful.
Yes.
Yeah, because I was like, oh, it's...
Not
it's
third
I
degree.
saw the third degree. I could have sworn
Yeah.
I read the third degree.
Yeah.
And then I looked at it again with Miss D. I was like, oh no, just 3 terms. So I erased the third degree. Either way.
They did everything to the fourth then, and that's why it's all wrong.
Any other questions on 2016 in general or specific?
Yeah, why was it such a better year than this year?
Such a better year, you haven't done it yet. Oh, you mean in general?
I get it now.
I get it, not the AP. Senior year, a lot of stuff comes that you're not always ready for.
I just wanted to know.
Are we gonna get Burger King ads?
Yeah, we're getting Burger King guys? Yes!
It'll be a lot easier this year, there's only 6 of you.
I figured you were going to be like, no Burger King guys. I'm going to plunk you all on 2 tables right next to each other.
Well, I'm going to do that just for sake of simplicity of handing out.
Well, yeah.
So if you're all
There's 3
intermixed.
people per table, right? And then...
Yeah.
And then,
Alright, 2016, 5, 4, 3, 2.
One.
1. Done. Alright, cool kids. If you're ready or when you're ready, just go back and put it in your tray. That way I don't have more piles on my desk, because right now piles on my desk is not a good thing. Close all tabs.
When you see things at the end of the day?
Which one?
When you see things?
Yeah. I'll take both of them by the end of the day in my tray or in my box in the office.
Do you have practice for like cylindrical shrouds and logistic?
Oh yeah, I have all kinds of stuff. You ready?
No.
Party poopers.
Really quick, did any of you guys get C for the,
Yeah.
for 10?
They didn't
Anyone
get
get
that?
C?
Yeah.
It's the last problem.
Oh, I think I did.
I did.
Okay, can I see what your
Yeah.
thing looks like?
Did anyone want to pay for it?
This one? Yeah, please.
I grabbed one.
Is it go in the folder as D or?
Technically corrections in and when you see you think on top, but I'll take it either way. I was pulling it all out.
Alright, I'll just toss everything in there. So FRQ's in there as well?
Yeah.
Is this.
Alright, kiddos, what am I looking at right now?
Practice.
I have Google Classroom up, and then what else could I pull up if I really, really wanted to?
Everything.
The website AP exam review. Okay, but just to focus our attention, these are 2 articles I found fairly recently. I put in your classroom, I don't know, a couple days ago. The first one is an article specifically about calculus AB, but usually where you can find AB practice, you can find BC practice. Usually, just beware. However, the second one is specifically called, come on, network. Well, A. Khan Academy definitely has AP Calculus AB questions, like actual questions of AB, and scroll down BC, and he talks through all sorts of stuff, FRQs, etc. So that's not a bad idea to peek out if you want to talk about FRQs. Coming out of that, coming back here. If we look at the exam review on my website, the exam review tab, I have things like the 2006 AP Calculus, tons of different versions, and you can literally get a version and then sadly you can't select the answers. That's why I don't like this one as much, but it does have an answer key to go with the different versions, ABs and BCs. Over here in this article, it's a good one, but it specifically, once again, is about AB, but it does tell you about a lot of the different options. If I can get down to it, there we go. Khan Academy, Barron, Schmoop is the one paid one, sadly. But the other ones have free, all sorts of free. Albert is a great one if you want to review actual topics. Barron's has an online, I don't think I actually have it open right now, but Barron's has an online AB and BC timed, like you take it or non-timed, you just try it and it grades it for you. So for you guys, that'd be nice to get immediate feedback, what I get right, what I get wrong. But Albert, if you follow the link in the Google Classroom to the blog and hit Albert, there is a free portion of what they have. And they go through limits and derivatives, and Euler's method is in there, and parametric and polar and slope fields, and it keeps on going through. It goes to convergence, divergence. I think the one place I saw it kind of seemingly, oh no, parametric polar, there it is. So it does have all of you guys like intermixed within the AB content, and they have practice problems in all these at once. I'm not sure exactly how many you can do, but Albert has it nice and organized. The second article does say AB and BC, and it goes through and talks through. McGraw-Hill has, did I open that one? Oh, it's the same article. Oh, and now it just doesn't like me. But McGraw-Hill has a practice AB and BC test. Then it goes through different study guides, etc. There's one I think called Varsity Tutors on that other one that I had open a second ago from the Google Classroom. And that has, like, you try problems and it gives you the solution and what you were supposed to review in doing it. So there are some that are topical. There are some that are just like, hey, let's throw practice problems at you in random order. All of them are good in different ways depending on how you want to study. Does that make sense? All right. So, to that end, we only have a few minutes left. Do you guys have any other questions for me as far as tomorrow? Or as far as this weekend? No?
What
Don't
time
really
had
have
to
to
be
show
there?
up.
I'm passing out tests at 8 o'clock. So you want to be there, be settled, get some food, get some coffee. I'll probably be there by 7:15.
What time?
Mr. Williamson's. Mrs. Choi is where the food will be. Gerardo, go ahead.
Where do you want us to be?
Mr. Williamson's room. Is that not the question you asked? Did I get it wrong?
No, that was right. I wasn't being interested because I had something down for.
All right. You guys just want to work on corrections? I see you guys just working. Is that okay? Next week. But if you can cement down some of the ideas you missed, I mean, now is better than later.